This video will just give you a quick introduction to the code for this task. It's very simple, and as I explained in the handout, there's multiple ways you can run the code. So the first one we've got is a Jupyter notebook. This is how we designed the code originally for us in the workshop that we hosted, and this contains all the information that the student will need to run the task. So if you want to set this as an individual task where they go away and do it on their own, you can do that as all the instructions and everything they need is all within this one notebook. So it has an introduction to the workshop and the tasks they're going to do, and the coding task itself is split into 5 different tasks. So as we see here, it kind of looks a bit like this. So if you are familiar with Jupyter, you can just take the Jupyter file from the resources and upload it to Jupyter, whether you use Jupyter Lite or if you've got the software downloaded on your computers in the schools. It's totally up to you. So for example, it should look like this. This is the copy of the biomarker workshop for the students. There is a hard copy of this for the teachers too, where it's got all the correct answers. So there's a bit of an introduction, there's the step-by-step, and then there's the section of code. And most of the coding is simply just adding in the gaps. No coding skills are necessary for this, so it's available for all students of different experiences. So we'll say here, so for example, this bit here is just running the initial inputs that we need. So nothing is required for this coding section here, and that's all explained in the bit above. If we skip down a little bit here, the first part here, all they have to do is enter the data file, and the data file is called participant data CSV. All the instructions and the tasks in blue is where they have to do something. So they will just have to write in this section here, participant data, and then run the section and so on. And everything will print below here. So for example, if I skip down, it's the same section. They've got a coding section here, and this bit prints these graphs here for them. And it'll all follow on like this. And for example here, this one, the students need to edit some of this code, and that's why this graph hasn't printed correctly, because some of it is missing. So this is essentially the task, and then it prints different graphs and it explains step by step what to do, and it also encourages students to think about what's going on and try and interpret the data themselves. So it kind of goes through this, and like I say, the students can work on this themselves, so they can work in pairs. We do recommend for if you are doing this with like year 7 or 8 students who maybe can get a bit chaotic in the classroom, that you either run this as a class or you kind of run it task by task and like regroup after the first task and make sure everyone's ran correctly and got things to work. Otherwise it can end up a bit chaotic, or people get distracted, and it can be a lot to process. For older students, they might be okay with just doing this on their own, or if they find this a bit too easy as no real coding skills is necessary, you're also free to edit the code if you want to. If you want to remove any sections and challenge the students a bit, if they want to plot the graphs or change axes or things like this, you're free to do whatever you like. So this is the Jupyter notebook. There is a hard copy, as I say, for the teachers, where it runs correctly, and you can see and reference this and see if they've got things correct. So that's the Jupyter notebook. We also have a PDF copy of this. And it's basically just a PDF of the Jupyter notebook. So you can print this out, or you can give this to the students, and if you wanted to, you could just copy and paste the code into a Python interpreter if you just used Spider or something. So if you didn't want to use Jupyter, you could just have the PDF, you can go through it together, and they can just copy and paste section by section and run each section that way, which totally works fine and might be more accessible, or might be more familiar if that's what the students are used to using, Spider or any Python interpreter. So yeah, you can just copy and paste the code from here. And the third option we have is just the raw text files. So this hasn't got any of the text or any of the instructions, but this is just the raw code. It's the whole script. You can just, again, copy and paste this straight into any Python interpreter, and this is just a pure code, and you can run it all together at once. And again, we've got the student version, which has got some things missing, or there's the teacher's hard copy where it'll just work completely straight away. So there's 3 different ways we've presented the code here, and it's completely up to you how you do want to do this. Like I say, all of the information is on this PDF. It's got all the instructions, and everything in blue is for the students to do the task. This will be a good task, and it's completely up to you how you run this, and you've got the flexibility, like I say, if you want to edit the code as well.